And one of the aspects that I've said to be conscious or aware of, it's easy to be vocal here, and you really don't care whether you're right or whether you're wrong, because no one wants to look silly. Like, think of the first time you threw that javelin or something like that. You just think, God, what did I look like? So we're more comfortable with it now. Okay. So when that happens, when we're doing this question and answer, I think, again, more locally, it's very easy to do. Next fall, in a larger class setting, do you picture yourself being more vocal? Or if you think you might know, I'm not going to say anything, because probably not till you get there. Okay, so and I tried to tell that to everyone here yesterday. If you say something is wrong, so what? So that again, that happens. Okay. It's better than what I drew, although that top line should probably be a little higher. There, that's probably a little more accurate. Okay, so what is everything that you can tell me about this structure, or the human heart? What is that? This is the right side. How can that be left if it's the right side? It's a mirror image, yes. So this is the left atrium, okay? So then you want to go this way or down? Okay, what's this one then? Right atrium, okay? Left ventricle. Okay, so I'll give you a little bit of time if you want to write that down or something to that effect. Okay, so pop quiz, what is this? Yep, that is the human heart. Okay, so if we were to place that right here, it might give you a better idea of how not only it sits inside that of the mediastinum and thoracic cavity, but when we start talking about some of these structures in the heart, it might make a little more sense. Okay, so we'll come back to this, because I think maybe this will make a little more sense when we see this as we had talked about yesterday. Okay, so do you have all this content wrote down then? Is that accurate? Yep. Okay, so what we had done yesterday, as you're probably aware, is I believe this is where we had left off with last week, and then we began with this today. Okay, so with a lot of other places in the body, if someone may come to a clinic or a hospital, they appear yellow in color because they've got jaundice, and sometimes that happens because for some reason the liver is just not functioning the way that it should. And I believe Latin for liver is called the hepatics. Yep, it's hepatic is Latin for liver. So if someone has hepatitis, what does that mean to you with your limited knowledge with what you've learned so far? What might hepatitis mean? Yeah, an inflammation of the liver. So many different places in the body can have inflammations, and this is no exception here. Because if someone has pericarditis, then they've got an inflammation around what envelops the heart here, okay? Because there's a fluid sac that actually envelops the entire structure of the heart, and also some of the vessels as well. So then the epicardium then, as we can see, is the innermost layer of the heart. For some reason, I think that should say endocardium. I'm going to have to take a peek at that. Okay. And then with what you had drawn on your paper and what we had here, okay, the atria, of course, are your top two chambers, okay? And in a couple of moments here, or a couple of minutes, once we're done writing, I'll shut that overhead off. You have a better view of this heart structure then. So a good way of looking at this is atria are always receivers because it's receiving blood from two different areas of the body. So what is the difference between a systemic circuit and a pulmonary circuit?
Systemic is like more to the whole body, and then like pulmonary is only to the lungs.
Right. So what happens then is these are both receiving, okay? It's either receiving blood from the lungs or it's receiving blood from the rest of the body. Then when we look at the ventricles, those are part of the sending blood away in either the pulmonary circuit or the systemic circuit, okay? These really do not take part in either one of them circuits because they're not sending anything to the rest of the body or to the lungs. It's these two structures that do that. So you could say it's a fine line. I understand that, but it's kind of a trick question. Are the atria part of the systemic and pulmonary circuit? Yes and no, but they're just receiving blood from those two areas. And then, as we said, the ventricles are what sends blood either to the lungs or the rest of the body. So if you, of course, made a fine drawing like this one, why do you think is this side so much larger than that side? Yeah, because this has to pump blood not only all the way up into the brain, but it also has to send blood all the way down to the feet as well. So, and to all of your extremities. So this has to work. It's not that it's working harder, it just has to be bigger in order to send that blood to the rest of the body. That's right. Okay. So a septum. Why might that have to be, or septal defect, why might that have to be surgically corrected? It's not always the case. It just depends if it's a large enough of one. Why is that a problem?
I remember you saying it, but I can't.
Okay, so one way of looking at that is when we're looking at our circuits, okay, if this is sending blood to the lungs and the rest of the body, okay, a septum just mainly means a hole, and if it's big enough, okay, ideally, this is receiving blood from the rest of the body. And when it's coming from the rest of the body, is there oxygen in there? If it's coming back from the rest of the body. It does not. It has some oxygen, not a lot, because you've exchanged that and it's coming back from the rest of the body and then enters into the right ventricle. If this has low oxygen, this certainly will then too, because this has to send blood to the lungs as part of the pulmonary circuit. Then this receives blood from the lungs and it's charged with oxygen. It's going to have a lot more oxygen than what either one of these two chambers do. Then it's going to drain down into here so it can pump that oxygen and other nutrients, whatever, throughout the body. So if this has oxygen depleted blood and this has what the rest of the body needs, what can blood do within these two chambers? What's that illustrating? It's going back and forth. There's a reason why maybe at home you have your fat cattle sorted from your feeder cattle, because you really don't, because their diet really isn't the same. It's not like it's that big of a deal, not nearly as important as what this is. But if this gate is open, well then that blood can go back and forth and you're sending oxygen poor blood not only to the rest of the body, which is bad enough, but it's going up towards the cranium and into the brain. Then you've got problems. So it depends on how big that hole might be and when a cardiologist would say you have to have that surgically corrected. Then we talked about these two valves, and and then we talked about them as well. Okay. So what might be a trick to keep this separate from the mitral valve or the bicuspid?
The tricuspid side of the lungs has 3 lobes.
Man, you're taking the advice from, which is fine. That's what they said in class. See, I never thought of that, and that makes sense too, because on the right side of the mediastinum, that lung has 3 lobes to it. Of course, then you're associating that. I've just always looked at this and said you have a tricuspid on the right, a bicuspid on the left. This has an R in it, so that's why it's on the right, and that's just what works for myself. Then we know pulmonary is just a generic term for what possibly? When we talk about CPR, what is the P in CPR? Cardiac. Yeah, pulmonary resuscitation. It means lungs then, okay? So then this is a one-way valve that will not allow blood to flow back from the pulmonary artery, okay? And that actually helps with the different heart cycles that we'll be talking about just briefly tomorrow. Then on the left side of the heart, you have that bicuspid valve, okay, between the left atrium and left ventricle, and of course the aortic valve, which is the best way to associate that. If it's the pulmonary semilunar valve, you know it's in the pulmonary artery. If it's the aortic semilunar valve, you know it's going to be in that of the aorta then. And I had some heart models. They're back in that storeroom somewhere. I think I've got 3 of them, and I need to locate those so we can have a fresh view of those on Monday, which your next track meet I see is on, oh, you'll be here on Tuesday. Okay, you don't leave till after dinner. Okay, so I think tomorrow I'll possibly talk about that a little bit, but you're going to see why these chambers are going to be larger than the bottom's larger than the top. Okay, so what we see here then, okay, is, again, you're looking at this mirror image, and this actually does flip open, and the aspects of this, you really can't see some of these valves unless you tip it on its side like this, and you'd have to look really close. So with that, I think when we talk about path of blood to the heart, that's maybe what I'll do tomorrow, and utilize this as an example as well. What happens is you have blood coming from the rest of the body that's draining into this very large vein, and it's coming from the rest of the body from the bottom in this very large vein. Is there any chance you might know what that is? It's something cava. Starts with a V, not vein, but I didn't know if you did that in health class. Okay, this would be the vena cava then. And since this is coming from the cranium area or the brain or somewhere in the upper extremities, and this is coming from below, this is the specific inferior vena cava, and this is the superior vena cava. That blood is coming back within the systemic circuit, coming back into this right atrium. Okay, so it pulls down into this right atrium and then goes through this valve. So what valve is it that separates your right atrium, excuse me, your right ventricle from your right atrium? Right. And then when you look at this, you'd have to have a better view. There's a cusp there, there's a cusp there, and then there's a cusp here on the bottom. So that's why it gets its name, being the tricuspid then. Because what happens is as this contracts, okay, then them valves will slam shut. and it just does not allow blood, ideally, it does not allow blood to flow backwards there. Okay, so now it's down in here into the right ventricle. And if it is part of the pulmonary circuit, does this have lots of oxygen in it? And you can use this as what we talked about earlier. So this is a depiction of this. In this right ventricle, is there a lot of oxygen in here or very little oxygen? Very little. Because this has to go to where for oxygen exchange to take place. Yeah. So then this is going to leave through here. And the trick question that we said yesterday, are all arteries red and are all veins blue? No. It's something that is just a general terminology that you might learn in elementary. And at that level, that's fine. Because as we see here, the better depiction is this is actually a vein, or excuse me, this is actually an artery, because it's sending blood away from the heart in the pulmonary circuit. So what happens is this pulmonary trunk really goes to the left lung, and then what you can't see is actually underneath this aorta then is this pulmonary artery actually will send blood to the right lung. And again, that's something that you can't quite see. Then what's going to happen is oxygen and carbon dioxide exchange in the lungs, and then it's going to come back. But it's full of oxygen now. So again, what you can't see and what I could never draw is this is red, but it's actually a vein because it's bringing blood back to the heart, and this is the pulmonary vein or artery because it's red. It's a trick question. Yeah, it's actually a pulmonary vein even though it's red because it's bringing blood back to the heart. Okay, then here's the left pulmonary vein right here even though it's red. Then as it enters the left atrium, then it's going to go through what valve down into the left ventricle? The bicuspid or the mitral valve. And as you can see, it only has two cusps on it. There's one here, and then if I tilt this enough, you can see possibly there's one on the bottom. So that's what makes this the bicuspid valve. Then, as this contracts, it will send blood out through this very large artery, the largest artery, the aorta. And if you could see that from here, these two valves are right next to one another, this being the mitral valve or bicuspid, and then the aortic semilunar valve is further up inside of there. So then you have this ascending aorta. We talked about that. This is the aortic arch. Then you have the descending aorta that's going to go down into your thoracic cavity, abdominal cavity, down into the pelvis, and then down into the legs. We'll talk more about this a little later on, what these specific structures are. But that's basically what we had covered last couple days, really, on Tuesday and going back to last Thursday. All right, so that's all we have. We will catch up to you in person next Monday. We'll have just a little presentation tomorrow, so anyway, rest of the time's yours.